Okay, this Friday your test, Friday. Okay, chapter 7 will be a very big chapter. So we're going to go a bit fast today. So just to recap, we have 4 LO. Yeah, once you sign, you can go back to your place, or can take to your place to sign. Okay, so we have LO1, LO2 for your test 1. We will learn about the project management model, roles and responsibility. We already clear project scheduling and the cost already clear already. So now we at the LO4 approach used in product development. So chapter 7, chapter 8 will be more on product development. So they also have a few calculation, a few more equation to go through. Okay. So for the first half, we'll go through the product design process and then maybe some of the standards. So we'll learn about design process. Okay, first, what is effective design process? We have 4 criteria to define because as an engineering module, we always like to define something, right? So effective design process, we always link with the customer requirement. So for chapter 7, chapter 8, we always link back to what customer want. So effective design process, you link your product or services to customer requirement. Then you look at the cost, because project success also link with the time and cost. So you link the customer requirement with the least cost manner, means minimum cost, and then time required. And for design process, for engineering design, actually we try to avoid changes in the design, or in textbook words we call it revision or alteration. So 4 keywords for effective design process. You make sure you meet customer requirement with the cost within the time, within the cost, within the time, and then minimize the necessary on the drawing or on the production process. Okay, so these are the 4 keywords for the effective success. Now, there is a very important diagram that you see for this chapter 7. It is the question might come out in the final, ask you to draw this whole diagram and then explain one particular process. Okay, so this is the very important diagram. Again, this is a very important diagram for chapter 7. Right. So we start with a few main blocks first. We start with idea stage or idea generation. Then you go into feasibility studies. Then you go into fabrication. Fabrication, in this module, for product development, we will touch something known as rapid prototyping. Okay, so idea, then go into studies, then go into rapid prototyping or fabrication. Now, once you go into rapid prototyping, you will go into the final test. After you have the sample or prototype, you go for the test, then you release the product as a new products. So these are the main block that we go through one by one in chapter 7. Okay, so again, this is a very important block diagram. So okay, so we start with the idea generation. So idea generation, still go back to the first slides. We need to identify what our customer want before you design anything, before you develop any products. You have to go back to the customers and then ask them what actually they are expecting. Okay. So how do you get your ideas? How you get idea? There are a lots of sources that you can get at the idea generation stage. Okay, so the keyword here, the final goal of idea generation is to meet customer requirement. So the next question is how? How do you generate idea? So these are the sources that you can get for your teams to develop the idea. So either from your own R&D department, you have the archive, you have the previous data to develop R&D department, or you want to come up with a new products that solve customer new problems. So the next department you go is the customer complaint department or customer service department. So you always you go back to the reject department, you go back to the where customer return their not certified products, right? So you go back to the customer complaint, or you do marketing research through the new survey. Or you can go to ask your suppliers, your vendors that any new technologies that are coming back, like for example, any new sensors, any new processor that they plan or they're going to launch soon. So these are the things that you can go. And sometimes the factory workers, those that in the production floor, they have some new ideas as they very familiar with the capacity of the factory or the machine that they're working on. Sometimes they have new ideas on how to solve that particular issues. The last one is very important one. As you go back, as you graduate later, the fastest way is from the competitor. The fastest way to generate new ideas is to go to your competitors, right? So these are all the elaboration. So competitors, later we will explain how you extract ideas from your competitors. Okay. So the rest is just okay. Remember to sign things. Okay. Next one, we will give you a chart. It's called perceptual maps. Perceptual maps means you draw a map, and then when you do survey, you try to identify what is the customer needs, what the customer requirement. In this case, just give you an example. So there are 4 main parameters for a food company. For example, this food company is producing breakfast cereals. Breakfast cereals that they identify that these are area that customer looking into. For example, good taste, the breakfast cereals taste good, high nutrition, bad taste, low nutrition. So it's a quadrant of good taste and high nutrition, and then the opposite one. Okay, and then they fill in a few ingredient here or their products there. Okay, so cocoa puff, rice crispy, ready churros, and so on. Okay, so this might be not very popular in Malaysia. I myself, I don't take serious, but in the Europe or in the foreign country, or those cold weather country, they like cereals very much. So okay, so they identified that these companies, this is an example where you see that there's a lack of entry in the good taste and high nutrition category. So these are they don't have any products that fall into here. So what they do, they saw it as this blank here is a good opportunity for them to develop new products. So this is the new product that they launch when they do the perceptual maps for this cereal company. So they identified there is opportunity, so they create these honey nut cereals products. So this is the version they come out when they do these perceptual maps. Okay, and then they market it so and so. Another one is launched by this Kellogg's Rice Krispie. So what they do is that they put in a lot of taste inside there, reducing size and add more sugars, frosting, and berry filling, and all this. So you see a lot of fruits and all this. So they say they saw a trend of healthy food or healthy lifestyle. So you can see nowadays a lot of food products they try to add fruit ingredients or smell or anything that relate to healthy lifestyles. So then they will market it. So this is an example of a cereal company with using their perceptual maps. Okay. Again, those just come in. This is a very important chart. It might be a question come out. Just ask you to draft out this whole diagram and then explaining either one of these process. Okay. Okay. Next, in product development dimension or product development chapter, benchmarking is very important. Or when you go out there, you work in the R&D department. First, you will come across an idea generation. So idea generation, we already cover what are the sources you can go and get new ideas. The fastest way is from competitor, and then you do the analysis. The next one is do benchmarking. So what mean by benchmarking? Benchmarking means you refer to the best products in the market, and then you copy the performance. For example, okay. For example, you benchmark a company that can have an entirely different business model. For example, this American Express. What do the American Express they know for? What is the convenient or what is the tagline they use for American Express? Or maybe you guys haven't have one black card. Yeah, what mean by active members? What are the convenient as a loyal, widely used, and then okay, what is a convenient when they spend money if they have black cards? Okay, what is convenient when they buy things? Fast, the word is fast. So for American Express, they are known for paying very fast. Means no limit and so on. Means they can pay with ease. Another one brand, Disney World. Disney World, they are known for their employee commitment. Means you walk in there, every employee will feel very you feel their happiness. No matter how bad day they have, you will see the Disney World employee, they always give you a cheerful, very welcoming atmosphere. Okay, so even you feel not happy, you can log a complaint to the customer department saying that you're not feeling happy, and then you can claim refund for that. Okay, so that is their what they know for. And then one FedEx. So FedEx, you know lah, FedEx, they are known for very high speed in the delivery. And now they come out with another tagline, they can deliver anywhere in the world within 1 day. Okay, so McDonald's for the food consistency and so on, and also convenient, fast food and so on. Okay, so if you have more studies in McDonald's business model, you know that they have a very good system business model for their entire business. So this is why you do benchmarking. You look for the competitors, the best competitor out there, and then you benchmark, and then you raise the standard or you improve the qualities. Okay, so this another wording that you always hear after you graduate from your degree courses. You work outside there, you will always come to a meeting where the question will the owners or your CEO will always ask you to give a yearly target. Then they will ask, who do you benchmark for? It can be internal, it can be external. Okay. Another one is called reverse engineering. So these ideas very straightforward. So if you get your idea generation process from the competitors, the fastest way is you do reverse engineer. So reverse engineer means you buy your competitors' products, you come back, you dismantle it, and then you study what actually how it works. That is the fastest way you learn. Okay, so this is also if you study how China come back from a very low we call it underdeveloped country into nowadays very developed country. Right, one of the strategy they use to grow their country is reverse engineer. Even their reverse engineer is so good until all the big company run away from setting up new factory or R&D department there, because they know already. They know how China so good in copying the product. They copy even better than the original one. Okay, so this is called reverse engineering. These are a few examples. For example, Ford, they use this approach for their models, Taurus Automotive. So they copy from BMWs, they copy from others, Toyotas and so on. Okay. So we're still at an idea generation phase, the first phase. So another words is called R&D. R&D, if you are in the new, you want to develop something new, normally you start with the R&D department. Okay. And even nowadays, if you follow through some business studies, Kodak is a very famous case study they use from a film empire into a failure when the digital camera come on and so on. Okay, this is a very good example, right? So the rest you read, So we already done with the idea generation. So you have design firm, marketing, supplier, R&D, customers, new technologies, competitors. Once you have that one you have the phrase. The end of the phrase is what? What is the products? Is the product concept. You have the input and output. Input is all these things, all the customers, new technologies, and so on. Then output from the first phrase is product concept. Come up with the concept already. So after you have the concept, then you need to test whether it is feasible or not, right? So nowadays, we are very convenient. We have a lot of software that we can do simulation, right? You imagine 20 years ago, we don't have all this powerful computer power and also the software. But nowadays, we have one or two clicks, you can get all the information from the computers, right? So feasible studies is that you consider you have a market analysis, economic analysis, and technical analysis. So you have three types of analysis in feasible studies. One is market analysis, economic, and technical. Because when the final goal is to develop a products that the market will buy, that able to sell, and also able to meet the customer requirement or what the customer wants. So that one you handle by technical dimension. Okay. The rest you read. Okay. So most probably they start with customer survey, interview, focus group, market test, and so on. So again, when it comes to feasibility study, you already have the product concept already. It's like they launch. That's why you nowadays, if you're in the automotive, you can see a lot of like automotive concept car and all this. Why they have this concept car launch at a certain event? Because they want to do feasible studies. One of it is market analysis during the event, or then they will see the how the market respond, especially all those big buyers. They want to see what is the response of that. Okay. So once you have the demand potential exists, you will do economic analysis to project the production and development costs. Okay. So once you have that, then you go into economic analysis to estimate the sales volume, you do projection already. Once you have the data, you have the survey, you start to do projection. Then you start come with the price range that you want to sell. So very good example is the Apple launch event. They always surprise people with very good product in a very we call affordable price. Affordable, right? So yeah. So there is a quantitative techniques and so on. This one you read. Then at these feasible studies also, they estimate the risk for the new products. Because when every time there is a new product, there's a risk. Once you do it, once you launch it, then you're not producing 1 or 2 cars, for example. You at least you launch 1 million cars per phase. Okay. Once you do the economic analysis, then you go into technical and strategic analysis. So you ask all these questions. Okay. You ask all these questions. So I will not go through very detailed, but these are all the things that you need to do. Okay. Once feasible studies finish, the outcome from the feasible study is performance specification. Okay, so again, idea generation, the output is product concept. Product concept is an input for feasible studies. Output from the feasible studies is performance specification. So you have to know which stage, what do you come from, okay? Yeah, so specific performance specification is a written for product concept that pass through the feasible studies and approved for development. Means you have the concept already, then you have feasible studies, okay, everything green light already, then you go into prototyping, you do prototype already. Okay. Okay. So what is for performance specification feasibility studies? They describe what the product should do to satisfy customer needs. Okay. Performance specification actually tell you what should the product behave to meet the customer needs. This is the things. Okay. Now we already done idea generation, feasibility studies. Then we go into rapid prototyping. Okay. So rapid prototyping is quite a new word for the, I think for the since last 10 years, since the CNC machine can go for 5 axis, 6 axis, and then with the with the introduction of 3D printing, laser cutting, and so on. So now we have this rapid prototyping terms. So if you go Google, you type in rapid prototyping, you'll see 3D printer, CNC machine, all this. Right. So during rapid prototyping, the designers will go look into the performance specification and then transform into physical product or service. So in chapter 7, chapter 8, you have 2 main type of category. Means the one that you product development. Product development, it can be a physical product or it can be a services. Services also one kind of products. Okay. So you see the definition here is physical product or services that you get from the performance specification. Okay. So the process of this one, the process of rapid prototyping involve all this lah. You build prototype, you test the prototype, revise the design, testing until the a good design is formed. So the word rapid prototyping is rapid prototyping. Rapid means very fast. So prototyping is you make the thing out. So combine this rapid prototyping, it just means that you can test the product very fast. Normally nowadays, we'll use software to help us in rapid prototypings. Because it saves costs, and sometimes the material you can define in the software. At least earlier evaluation, you can save a lot of cost. Once the software or the engineering sound analysis proven that this concept works, then only you go and make one physical prototypes. Okay. So another word is concurrent. Concurrent is you do a lot of things in the same time or in parallel process. Okay, what is design decision? The design decision, they affect all those things. Design decision. Okay. So we already have effective design definition just now. So the diagram on the top here is a very old or typical factory setup or production setup. So what you do is that you have customers, then there's a wall, then you go to the marketing, then there's a wall, then you have engineering design, they design it in their own office, then you pass the information to manufacturing engineer, then you pass the information to production floor. So when you do concurrent design, you break down the walls and then they sit together, share information, and then they go concurrently. They go in parallel. Okay, this is called concurrent design. Okay, so concurrent design, it means it's not only not be confused with the word design. Concurrent design is mean it involve every parties in the companies or within the product development team that consists of sales until production floor officer. Okay. Okay, so the definition for technical definition for concurrent design is a process that jointly and iteratively developing a design. It means you combine all the process or the team together. Okay, so this is a shorter version of definition. Concurrent design is a new approach that involves simultaneous design of products and process by design team. Okay, concurrent is a simultaneous. You link concurrent and simultaneous together. Okay. So why do we introduce concurrent design in this module? Because it's a current trend that you works after you in the market now. So you cannot wait the information finish, then you pass to another department. You have to go concurrently. Okay. So so we want to improve the quality, and also we want to launch the product as fast as we can. Okay. The rest you read. And nowadays, when you do concurrent design, you will involve your supplier together inside the team. Okay. So for example, this example, inside the car, you have a lot of components. So when you develop a new product, you will deal not only internal design team, you will deal with your suppliers, ask them what are the latest material that are used that you can use in your new products, for example, cars, right? And then when you reach the final stage where you do assembly for your car, you don't need to design, you don't need to spend a lot of money investment in the small stuff. You just buy from the supplier assembly. So it means you go parallel. So there's one famous case happened last year, last 2 years, where Silicon Valley have one issue on the chip, processing chip. So they out of stock. It makes the whole automotive industry have an earthquake where they cannot launch new model. I mean, they cannot deliver the new model to the customers on time because Yeah, because they need the chip for all the sensors. Okay. So but now already solved already lah. Just that there's a good case study on that. Okay. Another one that definition is called form design. What I mean by form design? Form means you can touch things that are physical appearance, color, size, and styles, right? Like the car that you see on the screen here, right? It's a Mazda sport car. Yeah. So nowadays, all the products out there, especially when they contact with the customers, the functional design, it must be adjusted to their form design or to their aesthetics form. Okay, so it must look good first, then you look at the function. Okay, so it will be a very struggle for engineers because sometimes you want it to be performed well, but perform well sometimes you need more component and look big, look very very ugly because of the standard component you use. But nowadays you have software, you can fine tune the casing and all this, so it will look better compared to the old design. Okay. So for example, these two products, the Apple Watch and all this. Okay. So this is a elaboration on the application of form design. So this is a Mazda sport car. So what they do, besides looks good, they will change the exhaust so that the exhaust sound will sound good. And if you are a big fans for BMW or other sport car, now they even have a artificial exhaust sounds, or they have a sound cancelling technologies inside the car. Okay, so this is another level of form design. The gear shift, those like by sport car one, they like the gear shift, and even this one is that they adjust the seats and the doors properly so that the user can look cool. I mean the hand can put on the car there or on the window there. So there's a certain design why they design such a way because they want it to look better or feel better. Okay. Apple Watch you know lah. They look great and one strategy they use in their team, they call it Pixel Perfect Mockup. Pixel Perfect Mockup is a strategy used by Apple company when they develop any products inside the Apple. Their prototypes they do is not, they want to do it the first time as real as possible. Means that the first prototype that they present to their CEO, it must be the very near to the one that they're going to launch. Very old method is that you have a very ugly prototype, then you refine it, right? But in Apple, they already squeeze everything, so they only look at the final prototypes. It doesn't care how you do it, but you have to knock your head out lah. So their design, they pay quite high for the design engineer for the new products. Okay, so of course there are also others companies. So if you are good in design, so you have a lots of opportunities lah. Not only Apple or automotive, you can go for other companies that they need a very good design engineer. Okay, so you can, of course, you have to build your profile lah. Okay, what I mean by profile means the project that you handled before. Okay. Another one, once it's a form design. The some form design is outside look, how it attracts your customers. Another one is called functional design. So functional designs is like it not only look good, but it should able to perform according to what customer needs. For functional design, they concern about the performance specification that they get from the process, the earlier process. Okay, so if you know this picture, this is a very miniature robot that you can play with. So it's not only looks cute, but it can able to perform a lot of things, lots of cute things lah. Right? Because nowadays, modern people we will feel very bored every time. So we need something cute to entertain us. Okay. Okay. Even nowadays, some houses we have Tianmao, we have all these cute things. Okay. Okay. So there are three things, performance characteristics in this phase of design when we talk about functional. We talk about reliability, maintainability, and usability. So in the functional design, you look at these three performance characteristics. So when the question asks you, don't confuse with the question. So look for, if the question asks you, what are the phrases that inside performance, what are the three performance characteristics that inside the functional design phrase. So the answer we're looking for is reliability, maintainability, and usability. You ask you to elaborate one of the point. Okay, so three lah: reliability, maintainability, and usability. So the next slides will show you the elaboration of these three. What I mean by reliability? So reliability, it means is a tendency, the probability, talk about probability that they will perform well or according to the specification. So that is reliability. It's a function or it's a probability that the products will perform its intended function for a specific length of time. So here you got time, you got function, and under normal condition use. So this one, reliability, always linked to the product warranties. So how do you know that this product is reliable or not at the normal condition use? You go to their product warranties, you go and read this product can do what or cannot do what. So under what circumstances this warranty void? So this is all the reliabilities. Okay, for example, Dyson. This is a very new products. So of course, it's also I encourage my student go and try out job in the Dyson company in Malaysia context. If you are really like design stuff, okay, because they have a very strong engineering team there. So if you are like engineering stuff, you like to design, deal with prototypes, then go Dyson. Okay. For example, of course there will be other new companies set up later this year, so you can go and explore. So Dyson, this is a hair dryer. They have a guaranteed function, not only blow air for 1 year under normal condition. In their warranty there, they will write 300 hours operations. Okay. Another one is your car lah. If you drive car, So your car warranty is normally 3 to 5 years. It depends, or a certain mileage. Okay. Under normal condition, then you are guaranteed to have one-to-one replacement or free services and so on. Okay. So for example, any miss oil changes or you miss a period, if you buy a new car, normally they will ask you to fill in the logbook, use back in the logbook and then chop by the certified service center. So there's a logbook there. You need to, every time you go, you need to show the logbook. Honda, they have all these systems. BMW also have, or lots of car, they have this one, right? So if you exit the oil change or you miss it, then it will void the warranties already. So when you buy a new product, make sure you go and read what are the warranties inside there. What are the things you can do or cannot do. So for example, handphone. Nowadays, all the handphone, although they are water resistant, but read carefully the warranties for that phone. They will tell you what are the maximum depth that the phone can go in water. although it's a water resistant, but they'll tell you what type of water resistant there. Okay, so if like you go to a trip, your phone fall into the sea, it go more than 3 meters or 5 meters, then that's it. Okay, how they know that your phone go more than 5 meters or 10 meters? Because the engineering team already designed up to a certain they call it hydrostatic pressure, water will go inside, and then there's a sensor inside the phone. There's a paper there, water detection paper. So if the paper, if they open your phone, if you want to clean already, open your phone, the paper will change color. They will look at the paper. So if they detect that color, then they say, sorry, I cannot do anything. Your phone go beyond the warranties. So that is the way how they detect lah, for example. Okay. Okay. Product reliability is a function, again, is a function or is a probability of how they behave under certain condition. Okay, so there is an equation coming in for today. There is an equation to calculate reliabilities. They give you the first equation for today. Reliability of the system equal to the products of the components parts liabilities. Component number 1 times component number 2 until the last component that you want to calculate. There are two equations I'm going to show you before I go for a break. Maybe you go for the first one first. So again, this is the first equation for today. Reliability, there's a first equation for today. Reliability, component number 1 times component number 2, and so on. Okay, first equation. So how do you apply? How do you apply? So the question, if you have two component parts required, you need to combine two components, and it tell you that each component have a reliability of 90%. 0.9 is 90%. So what is the system? If you combine these two parts, what is the reliability of this part? Okay. So for example, this case, you combine this part side by side, connect one. Then the reliability of system, if you use this equation, you individual times individual, you get 0.81. 0.9 multiply 0.9, you get 0.81. 0.81 does it mean? It means reliability is 98%. Can work under normal condition. It can function at 81%. You know about the efficiency, right? You learn about efficiency, input and output. So it's the same idea. So what do you mean? What do you can see here? 90% individual, but when you combine, it dropped to 81%. It means the more component you put, it will drop the system reliability. The more you put inside there, it will drop because it keep on multiplying. And not all component is 100%. So even 99.9.99, you times 10 times also you'll get below being 80%. If you multiply 10 times. So this kind of system is called series systems. Means you put one component with one component, link them together. Okay, this is how you calculate the reliabilities. Okay, so these are already explained already. So what you need to take back from today's lecture is that you always go for the simple design compared to a very complex design because of this equation. Because the more the more component you put inside the system, it will bring down the reliabilities. Because things will break down. So the more you put in, and one component will affect the process. Yeah, makes sense, Okay. Okay, then the next question is, as an engineer, how you solve this problem, right? So for example, inside the car, you have all these components. One of it is the brake, for example. how do you solve this kind of problem with if you have brake problems? Because you know that if you still need brake, you still need brakes, but how do you solve? Because once your brake is compromised, then it's going to destroy other things also. Because without brake, you cannot stop and you're going to bang something, right? So what they do is that to increase the reliability, we have a replacement called redundant part. We put in redundant part. In this case, we put in emergency brakes. Nowadays, we have a lot of type of brakes. Okay, the way function. Okay, so there are lots of parts, lots of emergencies procedures there. So nowadays, if you buy all those expensive cars, the car have a lot of all these redundant systems. Even you want to slip the car also cannot. It's so stable and it's auto correction, a lot of auto correction. Okay, so another before we go for a break, another one. Just now we have series, right? Now we introduce you the redundant procedure. Redundant procedure means you put a backup on top of that part. For example, the brakes, but you have a backup brake to stop the car. So in this case, you have the original, but you put a backup. Maybe the backup is not as good as the original one, but you put as a backup. That's why the old cars nowadays, the new car don't have a spare tires anymore. But the older version cars, you have a spare tires. So that spare tire is also one of the redundant parts. Redundant parts to increase the reliability of the car. Okay, so when you have this parallel system, for example, original 95%, backup is 90%. The equation rate previously you learned cannot use already. There's a new equation for that if you use redundant part. So you need to use this equation. The rest you read. I just go very fast for this one. If you use a backup systems or parallel system that you mount on top of the original parts, you use this equation. Means the reliability of systems that using parallel is 1 means 100% minus bracket 1 minus the original one, R1, bracket 1 minus the second component, bracket, and then continue to multiply until the last components. It's not that better or not, but it is a way to define this method is to define what is the backup efficiency that you need to put. What is the minimum backup so that you don't compromise the overall reliability? Later, I'll give you one tutorial question. Yes, series you know, right? It's a continue one, connect one. This one is go parallel. Parallel means it can go like this. So means if this side got something, this side got something, if this one break down, the system can go up and then come back. Means you can replace it. Yeah. So these are two equation. Okay, two equation. So for example, this case, how you substitute the value. So you have 95% original and then backup. Again, bottom one always original. Then on top of the original is a backup. So the first one, you know, original 95, you put in R1 as 95, R2 as 90, then only have two components, so no more bracket. So what is the answer you get if you have this one? Press and then we go for a break. What do you get if you have this parallel system? Okay. You have 0.995. You see how the reliability increase. Reliability, if you have backup, it increase to 99% already because you have a backup systems. Means you know that, okay, this thing, even if fail, you have something to replace it. You can have a second chance of using it. Okay, so we stop here, then we do this exercise. Okay, we have maybe 10 minutes. We continue 4:05, 10 minutes rest, and then we continue. Okay, this will be the coming tutorial question. Okay, those just come in, remember to sign your attendance.